Welcome to testing of materials, lecture number 2, mechanical testing. The previous video, that is lecture number 1, we have seen what are the materials we will be using and what kind of testing we will be using for testing the materials. And in this lecture, we will be seeing what is mechanical testing. So the mechanical testing, it is nothing but the material will be under dynamic and static force. I mean, the materials will be giving dynamic and static force constantly to the material and be checking the quality of the material. So those kind of testing we call it as mechanical testing. Okay. So this mechanical testing, it is also called as destructive testing. Okay. So once we do the mechanical testing to the material, we can't able to reuse the material. Okay. So not like NDT. So this mechanical testing, uh, from this mechanical testing we can find tensile strength, compression strength, impact resistance, uh, fracture toughness and fatigue. So the materials testing study reveals the behavior of materials under different loads, in particular the relationship between the active forces and the resulting deformation is found, in which the limit stresses that lead to failure of components are considered. To assure the performance, safety and reliability, it is necessary to avoid excess deformation. Because if we give the excess deformation to the material will break, or the material bend, twist, or the material will be getting stretched. Okay. So we have to assure the performance before giving the force to the material. The study of deformation and fracture in material is called mechanical behavior of materials. Knowledge of this area provides the basic for avoiding these type of failures in engineering applications. One aspect of the subject is the physical testing of sample material by applying. So here mechanical testing is nothing but we will be giving some force to the material and be checking that material. And what are the things, what are the mechanical properties we'll be checking, like strength and hardness of the material, and then stiffness, then elasticity, plasticity. So these are things we'll be checking while performing the mechanical testing. Okay. The first one, it is the hardness test. There are many kinds of mechanical testings are available, like hardness test, grip test, tensile test, or shear test. There are many tests. There are many mechanical tests are available. So one of the mechanical testing, it is the hardness test. Okay. So the term hardness is a structure sensitive mechanical property of material primarily associated with surface. If a material is uniform in composition and structure, the hardness measured on the surface layer will represent the plastic deformation of the surface. So classification of hardness test. So hardness test is classified into mainly Brinell test, Vickers test, and Rockwell test. So here the difference between these three mechanical tests are like the intended is the main difference. Okay. So we'll be using different intended for different kind of testing, like Brinell, Vickers, and Rockwell. Okay. So what are the selection criteria for the hardness tester is like we have to test the load, then we have to identify the hardness range, then we have to identify the accuracy level of the material. Okay. So these are the selection criteria before going for the hardness test. And the benefits of the hardness tests are like it is a very easy method. You can do this test very easily. It is an inexpensive. We can do the test as soon as faster. It is quick, and it is non-restrictive. May be applied to samples of various dimensions and safe. May be performed in. And the next one, it is the Brinell hardness test, the standardized method for quantitative determination of the indentation hardness, which was the first widely accepted indentation hardness test known as Brinell hardness test. The binal harness test consists of forming an indentation by forcing. Okay, it will be giving some force to the indent, and that indent it hits the material, and from that we can able to find the harness stress of the material. Okay, so the indenter may be diamond shaped or spherical shaped. Okay, so the dimension is given like 2.5, 5 or 10.5 mm. And the principle of indenter is an indenter is forced into the surface of this piece, and the diameter it varies. The diameter is mentioned like a small d. So the major components of the Brinell test are Brinell harness tester, Brinell microscope, indenters and plungers. So indenter is it is nothing but a part which touches the material as we give force to the indenter. So indenter it is movable and the test specimen it is fixed. Okay. The next one it is working. How it works, the surface of the test specimen must be either machined, grounded or lapped or polished. So first we have to clean the material, then we have to place the material in the anvil. After placing the specimen in the anvil, we have to test the table, apply mirror load to bring the point dial gauge to the set positions. So then we have to arrange all these things, and we have to apply major load by means of intender. And we have to monitor the load from the system. We have to maintain the load. Then after 15 seconds, you will be taking out the specimen and you will be measuring. And the applications are like so this kind of test is mainly used in cement dented carpets, copper alloys, steel, so cast irons. So like these in these materials we'll be applying the harness test. We'll be using the harness test. Then advantages are it is very high accuracy, and we no need to go for the trained operators. So it's a quick operation. So these are the advantages of the harness test. And the next one it is the impact test. So impact test it is nothing but we'll be giving some impact to the specimen. I mean the material which we have to do the test. So those kind of tests we call it as impact test. So impact test is a dynamic test carried out with notched specimen known as notch bar impact test. So the methods are like impact blow may applied by means of dropping weight on the through a swinging pendulum to the test specimen. So specimen is structured. Then from that we will be calculating the flexural load, tensile loading, compressive loading, and torsional loading. And next one it is a bend test. So bend test is a standard method. So we will be bending the material by means of some kind of procedures to calculate the bend test. Okay, so here the principle of bend test is bending tests are conducted by placing a length of material across a span and pushing down along the span to bend the material causing a concave surface or a bend to form without the occurrence of fracture are the typical performed principle for this bend test. The next one it is a shear test. So in shear test, force is applied to the load and the specimen is attached to the two ends of the stationary part. So the principle of the shear test is like we have to give the force that causes the material to slide against it. The specimen is loaded in shear fixers. Load is applied perpendicular to the specimen. So by this through a puncher. So we will be applying the load through a puncher. So by this we can able to calculate the shear test. So there are many different types of shear test. Shear test is classified into two types: single shear test and double shear test. So the components which we require for doing this or to perform this shear test is vernier calipers, shear fixtures for holding the specimen. So these are the things we have to keep in mind while doing the shear test. Okay, so that's all about the mechanical testing. Thank you.